Okay, good morning, everyone. It's 9 a.m., so we're going to start the session. There are a lot of presentations during the morning, so we try to go straight to this. Well, first of all, I would like to welcome to this RUC APS session. RUC APS is a European grant which is looking at the exchange of staff within the institution so that academics and non-academics can collaborate to produce research. The main theme of this project is about how to deal with high uncertainties and risk in agriculture within a value chain point of view. So my name is Jorge Hernandez. I'm the project coordinator, and during the morning we will see a lot of presentations that are around the project. And the main purpose of this is that you will find a possibility to probably try to join the main activities of this project. The session is recorded, by the way, so today in the afternoon the videos are going to be uploaded into the website anyway, so you can watch them later in case you miss something. Let's see if it works. Yeah, as I said, the project started in 2016. It's a 48-month project, 1.3 million euros. And just in case, that is the website. This screen, for some reason that I have no idea, is not working. So if you feel like, for instance, sit in this side to see better this screen, or maybe there, or if you see well, both screens is fine, right? So, but just apologize for this screen that I have no idea how to fix it. Sorry. The project starts from the idea that we want to help agriculture stakeholders from several angles. When we say stakeholders, we are looking at from the breeding point of view, when you start developing the seed, till you get that product into the market. So that's why we call this is an agriculture value chain project. Now, of course, that agriculture is not new. None of the uncertainties in agriculture are new neither, but something is happening that regardless we know all the uncertainties in this environment, there still is a lot of challenge and open questions that should be resolved. In this particular project, we use one particular concept, which is a participatory approach, which means that we're not looking at identify a problem, disappear for a year, and then come back with a solution that eventually might not be valid. We like to interact frequently with the stakeholders so that the solution can be validated in a regular basis. And the main purpose is to generate value. So how, with the thing that we do, we can do that. Of course, that all what I say is obvious sometimes, but in practical terms, when you want to combine stakeholders from an agricultural value chain, you will find that there is a lot of angles to be covered. Right? It's not just about farming, it's about supply chain, it's about technology, it's about innovation, it's about project management. There's a lot of things that have to be covered. So the RUC APS framework is trying to engage with all those dimensions. The project has a vision and a mission, of course, so we want to be a consolidated international team that can help in this challenge about supporting agriculture value chain once dealing with high uncertainties and risks, basically that. Why is this? Because it's a challenge that still is open, either in the research, either in practice. So we are just in the right place for working together to propose solutions. Once we talk about supply chains, this is basically the view that we have in our mind. So we have a farmer that is producing things. Of course, the farmer has a lot of suppliers, a lot of innovation and development in this side, and from here we start moving till the end. Why I use this picture in particular? Because once we talk about agriculture value chains or agriculture supply chains, the farmer seems to be not that relevant, right? So we look a lot about how we can develop a technology, how we can understand the supply chain, how we can do the innovation and all the stuff. But then eventually a question arises. What will happen if we take off the farmer right? So what about if we stop supporting them? So no solution for them, we just take them off. Nothing of these things is going to work. So literally there will be no food. So in this project, the farmer is the core, is the center of our studies, right? Considering all the other elements in the chain. As a source of uncertainties, as you know, we have a lot of aspects. One of the very well known is climate change, so we will see a few things later. This is generating a lot of things, not just about the increase of humidity, the increase of hot days and so on, but it's generating a lot of things regarding to pest, disease, efficiency, yield, that makes this supply chain structure very inefficient and generate a lot of waste, right? And the most interesting thing is that those changes are happening quite fast, that are very difficult to predict, which is the other problem. So people need to create some kind of ideas on how to predict this, where in the past we used to have a model that can predict easily next years. Now, if we can predict the next month or the next 2 months, that will be very lucky in some way. So we need to generate a lot of hypotheses, assuming that the things are going to be like that. And of course, that leads to a lot of inefficiencies in the process for everybody, eventually high cost. So, just to summarize it a little bit, the project is composed by 16 partners. The majority of them are in Europe. We have the UK, Spain, France, Italy, Poland, and also in South America, we have Chile and Argentina. The main of the partners are universities and industry partners. And from the industry partners, we have from the private and the public sector. From the public sector, we have mainly ministries of agriculture, so that we can be sure that we are targeting policy-making challenge in this sector. So that every partner has different roles, they can do different things, and the idea of this project is that based on different knowledge from different regions, we can learn from each other. So one of the questions, when the proposal was set, is that why, for instance, in similar latitudes, you can see that, why the yield or why the production efficiency for the same seed with the same conditions were exactly not the same. So a farmer is something that they would like to know. Because a seed, for instance, that is bred, let's say, in Netherlands with certain conditions and says, well, you put all these things into that seed, so you should get all this amount. They do the same in the bottom of the world, and it's not happening the same, right? So there's a lot of things that should be covered. So for farmers, this project is very relevant. So people from the farming side are very keen to know what is happening in Europe, but also people from Europe would like to know what is happening in South America, because eventually there could be another potential collaboration and potential business in the future. So the team in the project, we are more than 100 researchers around, very friendly people, right? So we like to talk a lot, we like to meet. We have a WhatsApp group with 80 participants, so we talk like we know each other every single day, 80 people, and which is very nice because you can go to everywhere, and it's really like you're going to your own home. And that makes things very interesting, right? Because once you know people from a more personal point of view, the people really get open to tell you more things, and then collaboration really can get crystallized seriously. Because it's not just a project to share ideas, it's how you can really connect for the long term, which is very interesting. In terms of main milestones, we have 4, right? We are in the year 3 at the moment. We are really looking at how governance and policy factors affect the agriculture value chain. Because we noticed that in the first 2 years, once we identify the main sources of uncertainties, we noticed that regardless what you can really do, if the policy makers are not aligned with those solutions, nothing really matters in the end. So you can provide good solutions, but eventually they're not applicable.
Sorry to interrupt.
Please interrupt all what you want.
When are you going on your break? We'll get this screen fixed.
Okay.
When
I get to a break?
When?
At 10.
10 o'clock, okay.
So see you at 10.
Screen at 10 o'clock.
Thank you.
Thereafter.
Right. That was prepared so that you can pay more attention now. Then, and finally, in the 4th year, right, we're looking for how we can do or implement validation, but of course, social innovation. So how we can make social awareness of all this, because there is another question. We can put a lot of effort in doing this, right? We can put a lot of effort in making the agriculture value chain, making more efficiently work and so on, but is the society really aware about all those efforts? They really appreciate all this, you know? So anybody cares about these things, or it is just another project that gets funding to do things? So the idea is try to disseminate things, to involve society in this. So this is basically the 4th year. So right now, in the year 3, after identifying the key sources of uncertainties, the main ones, now we are looking at how we can deal to impact at the policy-making level in general, right? The project, as you can see, as a multidisciplinary team, is composed by all those countries, and they have different competences. So the idea is that different competences should be complementary and people start working together, which means that if you would like to go to Chile, you know what is going to be there. If you go to Argentina, if you go to Italy, France, Valencia, Spain, Poland, you know, so you know more or less what they are the competencies. So the idea is that you start setting up the collaboration with them based on that. Now, the project, the good thing of this project is that it works like a platform, which means that it's not only set to the main project aims. You can look also for another type of collaboration or another type of project that you can develop around this concept. So, and actually that is basically at the moment what is happening, because we start talking about crops, but now also we're talking about dairy farming, also we're talking about livestock. So a lot of things after this initial understanding 3 years ago about agriculture, now we are looking at different type of commodities. In terms of impact, the project is looking at the moment, several dimensions. So in practical terms, we are looking at, in the agriculture production systems, because all the uncertainties in the environment, there is a lot of things with pests and disease. So there is the concept of integrated pest management, right? So the people, actually you will see more about that later, people from Italy is here. We're looking a lot about technologies and how we can simulate potential scenarios. So then people from technology is there. And then jointly with Ministry of Agriculture from different countries, we're looking a lot about regulation, quality, and standards, where a lot of economical aspect also get into, right? So those are basically 3 main dimensions in terms of pilot, but also we're looking at several other things, like agriculture production systems, interoperability, which means that when you have different systems that cannot connect directly, you need to create like a bridge sometimes, because the idea that everybody will use an iPhone 6, for instance, to communicate is not that simple. Eventually people have an iPhone or an Android, then you need application for both. That means interoperability, create that bridge. We have aspects like climate change and of course value chain economy. So after 3 years, right, we were on a huge brainstorming between all the agronomists, scientists, academics, industries, companies, Ministry of Agriculture, Institute. This is one of our final picture that can really summarize the key elements when you can really produce an impact, right, a change really in the agriculture value chain seriously, combining with the knowledge from different people. So, which actually has been a very good achievement, actually. So, just let me show you, for instance, one of those examples. In Italy, for instance, one of the projects that we are doing there, they have a very big machine, right, in Asia, right? They have a very big machine. That machine, what it does is that take literally pictures from those crops, right? So then we can see the phenological behavior of that particular crop. So you see that here are different chambers. So inside of each chamber, so when it goes inside, it takes different pictures, like with X-rays and ultraviolets and a lot of things. So then you can get different pictures. Now, that machine is one of the most advanced in Europe, right? Now, also is 10 years old, correct? And is very inefficient. So the people that is using this machine, they are mainly agronomists. So they had a question about what we can do in order to make this process more efficient, how we can understand what is happening, considering that we're expert on this and we have no idea to see how this is really working. So the management school went there and using all the knowledge in modeling and simulation, we tried to observe what was happening first without being an expert on this. And we were able to conceptualize the process. So all what was happening there after a month, basically, we translate that into a simulation model. So all what is happening in reality, we were able to identify key variables, key risks, resources, people, times, routes, sequence, and so on. Right? So how this is really helpful in the end? Because when this is running, right, when the simulation is running, you can really try a lot of scenarios. Right, actually, this is the person that is working, so you can see that here you have different plants arriving. This is the pot that is going through this belt, and then eventually goes into each chamber, which takes a time. So literally, with this type of a model, then you can say, what will happen if, for instance, I have a different chamber, or if I use one chamber, or if the chamber goes faster, or if I have 3 people working here. So this type of a model eventually can easily help you to understand what is happening, and that add value to the decision makers that want to know how can I do these things better, because in our case, it was not about to tell them how they should do their studies, because they are the agronomists, right? I cannot tell them how to do it, but I can tell them how you can do things more efficiently. And this is basically one of the good results of this project. And the idea also happens in the opposite, because I'm from the management school, right? I'm not an agronomist, but by talking with them, I learned a lot about agronomy. And then I was able also to evolve the model in order to make it more realistic. Of course, this is just a representation of what is happening, so still we can say that probably there is no value add on that, because you know, when someone sees this, they say, well, this is exactly what I know, so what is the value add of this? These tools are very interesting because they have an optimization mechanisms inside, so you can really tell them, for instance, if you want to play with certain variables, you can tell them what is the exact sequence, right, in order to, for instance, get the maximum amount of productivity, the maximum amount of usage, the maximum use of capacity of your system, you see, and then is when we add value, right, because we can tell them, look, we try 200 scenarios, basically, and from those 200, those ones that are in yellow, basically, are the key ones that you can really use, you know, that will eventually answer your requirements and will answer your questions. So, of course, that is the model also tell you that there is no one solution. There are several solutions. And this is how, for instance, people that is not expert in this domain can really see the value of this. Of course, they are not the one that are going to do it. We are the one that are going to do it. But still they say, all right, here I have a help. Here I have something that I can really use and learn, just to give an example. Of course, that the collaboration, this is management school, agronomist, right? But also we have other teams like engineering, integrative biology institute. A lot of type of people can really enhance themselves just by visiting someone, have a talk for like a week, and then eventually start developing your own solutions. So this is something that is becoming very powerful in the project, and actually is happening across all the partners. Now, the idea of this project now is that to open the doors for people that will be interested. The idea is try to give the opportunity to people to get involved in this project, especially potentially PhD students who would like eventually to enhance their work, probably add new case studies, go abroad and try to see what is happening, try some hypotheses, or maybe try to generate new collaboration. So here you have a set of potential research projects at the PhD level that were set by people from the agronomy side and also from the management side in this case. So those ones from here are from Chile, for instance. People from Chile said, well, we have all the facilities to try all these possibilities. like genetic analysis in native mice, for instance. Italy is looking at abiotic stress resistance, and in the management side, we're looking at a lot about economy analysis in the value chain. So the purpose of this is that the door is very open, right, in case you would like to get involved in this project. Because now the idea is that the RUC APS project should turn into a platform and help people to collaborate and engage as much as you can with more people abroad trying to understand different challenges. And who knows, you may enhance your network possibilities. So this was a very brief summary. Now we have a program to follow. We have people that is going to discuss the thing that they are working on. From 9:20 till 12, or 1 more or less, we're going to keep doing this conversation, so people will be here. And as I said, session will be recorded. And that's why I want to share the videos later on, so you can watch them later. One last thing, if you can, it will be really nice if you can access this website, access that code, and input keywords that you think that can reflect what you learned during this session, right? So then we will see the results by the end. So it's, the code is 76827. Then you go to menti.com. You will see that when you put that code, there is a space to put those keywords. Try to do it during the session. I will remind this by the end as well, right? So just in case you forgot it. So this is by the moment. So I'm going to give the talk to Martin. So want to come?
How are we forwarding it with that?
Yeah.
Thank you, Jorge. Good morning, everybody. I'm Martin Mortimer. I'm one of the directors of the Centre of Excellence for Sustainable Food Systems, which we have here at Liverpool. It's been going for a few years. Jorge was incredibly kind to me. He rang me up at short notice and said, can you give me a talk? And you can talk about anything you want. So I thought, RUC APS, production, sustainability, common words. So I thought I'd talk about sustainable intensification in agriculture. I thought that'd be relevant. And then a moment's reflection, and looking back at the literature, suggested that phrase had lost potency. It had lost perhaps meaning, and it had got wound up in a lot of academic discourse and discussion, because effectively it's a paradigm. And academics love paradigms. They write enormous long papers on paradigms, and they probably recycle other people's ideas. But anyway, I still thought it was relevant to talk about, but that's where the where next comes from. So I'm going to talk about some paradigms that have evolved in relation to global agriculture, and this is going to be quite broad brush and not necessarily context specific, but I hope that what it'll do, it'll promote some discussion and cause some argument, because that's what I want to do. So that's where we're going to go. The reason for a drooping sunflower is to remind me to just make the point that, in fact, is sustainable intensification in agriculture a dead topic? Is it a drooping topic, or can it be regenerated? And I'm just going to talk paradigms, by and large, and I'm going to apologise to those of you who've heard a lot of this before. This might be Food Security 101, but I'm going to try and put some different nuances on it. Okay, so everybody knows about the Green Revolution? Yes? Does everybody know about the Green Revolution? I've got a shaking head there, that's good too. What about the rest of you? Just too polite not to say? Oh, you do know, thank you very much. Okay, so you can correct me if I'm wrong. Okay, so the Green Revolution. Okay, who is the architect of the Green Revolution? I'm drifting into undergraduate teaching now, I apologise for this, but let's try and make it interesting. Who was the architect of Green Revolution? There's a guy on the left, a guy called Norm Borlaug. He was an American plant breeder. He was funded by Rockefeller, And there was a response to the end of the Second World War, and particularly famines in Asia and Africa. And within something like 10 years, he had increased yields of major crops, rice, wheat, and maize, certainly threefold, if not fourfold, simply by using modern plant breeding techniques at the end of the day, doing wide-scale crossing, and then allowing those new varieties, modern varieties, to diffuse into what we now call lesser developed countries. And that program of germplasm improvement has averaged gains on a per annual basis of a bit less than 1% for major crops throughout the region, a consequence of plant breeders getting together and doing things. And you might argue that the Green Revolution, which certainly increased yields dramatically, was only about plant breeding, but it wasn't. It was about breeding modern varieties, what we call germplasm improvement. It was about using inorganic fertilizers on massive scales, much more than had been done before, particularly in less developed countries, and also producing infrastructures for standard crop management, reducing risk and reducing uncertainty. And in the context of rice in Asia, it was about transplanting, top right picture there, into standing water and transplanting at particular known plant distances. And that had major impacts, was incredibly successful. It alleviated famines, and it alleviated civil unrest. And it wasn't until 2008 that we saw civil unrest kick back in relation to food systems. 2008, 2012, it's the spikes there. This is a graph simply of years against FAO's food price index. And then in the little diagram here, you can see that the food price index from the 1990s to about 2006 was remarkably stable. It fluctuated because of market demands and availability and all of the sorts of things that affect food commodities. But it suddenly changed in 2008, and the response was, very simply, civil unrest, riots and deaths. And it repeated itself in 2012. Do you know what the reason was for the 2008 food price hikes and the consequent mortalities? That was G.W. Bush changing maize production in the US, pushing it into bioethanol production. Detailed analyses show that that was a primary driver of pushing maize prices up worldwide. Maize was widely exported by the US to developing countries. It became short, and the market couldn't respond, and that was civil unrest resulted. It's not a widely known graph, that actually. It happened again in 2011, running into 2012, and you can see the same sorts of things. The reason for that was partly market distortions in maize, but also because of global adverse weather events, the risks that Jorge was talking about a little bit earlier in relation to into the project. And you can see from May 2010 through to April 11, there are a whole bunch of factors, some of which were political, as in EU suspending barley and feed wheat import levies, but also a whole bunch of other issues associated to climate. That again caused a massive spike in food price indices, which was driven partly by the market, but also by weather. So, has anybody heard about the safe space concept paradigm? Okay. So, as a consequence of 2008, John Beddington, who was the government chief scientist in the UK, got together an international group to try and address these sort of situations, recognising that food was in short supply. Climate change was happening. There were still concerns about improving food security in developing countries, and they came up with this idea with the safe space paradigm. And basically what that, you can see this on YouTube if I don't explain it clearly enough to you. Basically your x-axis is climate change, going from low to extreme, and this is global food production. We're talking global food production from low to high. And what they came up with, and this was a major conference in Durban, they came up with the idea that with time, because climate change is effectively time as well, as a surrogate for time, there's going to be minimum global population food needs. It's going to go up. Same time, there is effectively going to be climate-constrained food production, and as climate change impacts on agriculture, that constraint is going to be increasing at the end of the day. So that gives you two curves. And the last one there, this one here, is how much does agriculture induce climate change and effectively alter climate food production. So that identified what they called a safe space, and after quite a lot of work, they decided this was back down 2012 in the science paper, that we're about here. If we carry on in this way, we're well outside the domains of safe space. Now, interestingly, that paradigm has not particularly grabbed politicians' attention. Perhaps it's because it's too difficult and because it's looking at variables which we're not comfortable with thinking about, particularly how you condense climate change impacts into a single variable on the x-axis. Now, okay, so where does this take us then? Partly that safe space analogy and paradigm led us to thinking about how much extra is needed to feed an increasing world population, whether it be 9 billion or 11 billion. And there are very considerable differences of opinion in how much increases there might be, anything from 60% to 110%. But what is interesting, when you look at those things and you think about whether we need more food or not, the average yields, and I'm not talking dairy, sorry Jorge, I'm talking plants that I know about. Look at the major staple crops in the world, and you look at those average yields, and they are averages, and there is a lot of variability around those averages. But in fact, the yields are remarkably low. They're better in higher income countries, by and large, but they're still remarkably low. In the UK, we can get 10 tonnes per hectare of wheat. In Egypt, you can get 10 tonnes per hectare of rice with intensive agriculture. But in fact, on average worldwide, the yields are exceptionally low. There's great opportunity, therefore, to reduce that yield gap in some way or other. But if we look at what's happening in terms of growth rates for selected crop yields over time, and effectively you've got them either as total cereals or broken down, and including the main crops and soybeans and sugarcane, the actual increases in growth rates for crop yields, as you can see from there, are declining. They're declining from way back from the 1960s to the present day. That decline reflects partly the achievement in many of these crops in terms of what can be actually achieved on farm in relation to potential yields as well. But also the fact that agricultural systems haven't really changed very much in terms of how those crops are grown. So we're looking at a situation where we might be reaching yield plateaus and the problems of producing enough food for future demographic demand. Coming back to Beddington's safe space, the whole issue about climate change is highly pertinent. And agriculture, I'm sure you're aware, contributes about 25% of global emissions at present. Actually, I think it's a bit higher, and that's the whole agricultural sector, but it does vary by commodity. And if you look at those bar charts there, you can see from the 60s to the 2000s, the kilograms of CO2 equivalents in terms of greenhouse gas per kilogram of commodity. And you can see that, in fact, going from the 60s to the 2000s, then those emission equivalents have significantly reduced in most cases. And this, just remember, is just per kilogram of commodity. If you multiply this by area over which these commodities are grown, then you get a totally different picture. But you can also see that for the dark blue cattle meat, you can see that the emissions for that commodity are still incredibly high, which is why we're getting tremendous push now from certain groups saying that we should not be eating so much meat. There are other pushes as well, and that may upset some people very considerably. That's something we can discuss about if you want at the end of the day. Anyway, so we have a situation where, over time, we're actually starting to see some improvements in terms of reduction in greenhouse gas emissions per kilogram of commodity. And that comes for a number of reasons. It comes across right the way across the supply chain, not only what happens on farm, but all the way through to what happens to the fork via the supermarket and retailer. So as that paradigm was developing, then quite separately, we see Stefan et al. And other groups, and I'll probably defer to Andy here, who knows a lot more about this than I am, because I'm going into geographical areas and areas of land use, that argued that there were, in fact, distinct planetary boundaries which could guide human development on a changing planet. There were 9 effectively planetary boundaries, and the paper, which is in Science, is interesting because they actually define what their planetary boundaries are in relation to risks of change and making planetary health unacceptable for human beings. And you can see that the ones in red there, phosphorus and nitrogen, genetic diversity, are ones in 2015 that were seen to be of major concern in thinking about how we utilise the planet. There are a whole bunch of other ones which are in zones of uncertainty, particularly land system change in particular, and of course climate change. That's, and again, an interesting paradigm, the idea of control variables that we need to understand and to be able to equate to human actions, and particularly in agriculture. Because a subsequent analysis of that shows that all of those where you've got the arrows indicate that agriculture is impacting on all of those planetary boundaries and has done so since 2015. Novel entities refer to pesticides, endocrine disruptor systems and so forth and so on. So putting that together against safe space, the idea that we've got to actually define a space, we've got to define that space in the context of planetary boundaries as well. So to come back to the title of my talk, Sustainable Intensification, this is what the Royal Society described it as. Basically, a goal for agricultural production where yields are increased without adverse environmental impacts and without the cultivation of more land. It was just an aspiration, actually, but because of the notion of putting together the word sustainable intensification, it encouraged a lot of debate and a lot of criticism as well, which is partly why it's gone out of favour. But if we think about it in terms of sustainable intensification, it was partly cast, that whole paradigm was cast in relation to lesser developed countries and developing things. So if we look here on the right, we've got what we might call intensive agriculture, the sorts of agriculture that's practiced in developed countries, UK, US, for instance, for our major cereal crops. And you can see some of the features there at the end of the day. And the argument about sustainable intensification was promoted very strongly as a development issue, thinking about agroecological farming. In other words, utilising ecosystem services to protect yields, to improve soils, to do a variety of processes which were partly dependent on agricultural systems where labour was cheap. So, if you look into the literature, you see sustainable intensification used in this context over here. But where effectively external inputs were reduced, there was much more of a circular economy in relation to how one used nutrients, with an emphasis on nutrient and water use efficiency. So that's the way, I guess, from about 2014, sustainable intensification of agriculture went, certainly in the literature. It can go the other way in relation to emerging technologies, and Jorge talked about that, particularly in relation to precision agriculture, the Internet of Things. We're seeing we're seeing in terms of reducing external inputs, real-time, sub-field scale, application of water, application of nutrients. Highly high-tech on a large scale as an emerging technology. I would still say it's in its infancy when it comes down to it. Industry hasn't fully adopted all of it at the end of the day. But we're also seeing, and I'm only just picking out a few of these given time, the idea of product supply chains being much tighter. And urban agriculture gives us a great example of how that might actually work at the end of the day. So another set of ideas in terms of sustainable intensification. But the criticism of the idea of sustainable intensification in agriculture was that it was about increasing yields, and regardless of effectively the utilisation post-farm gate of the products of agriculture. And this comes from, I haven't put the reference on here, this comes from Václav Smil, I have 2000, where he actually asked the question in a different way. He said, how many kilocalories per capita per day do we actually need, and can the system, the global agricultural system, provide that? And the answer is yes, it can, if we deal with the issues of reducing post-harvest losses, and these units are kilocalories per person per day, where it's assumed that 2,800 keeps everybody going per day. If we sort out the losses due to feeding animals, and we go vegetarian by and large, and then we sort out a few other things, then there are plenty of calories on the planet. But it's a supply chain issue. It's about an attitude of mind about how we use, particularly carbohydrates, in terms of both waste in our own systems and also in feeding animals. And then, of course, the other criticism was of sustainable intensification per se for raising yields was that it did not consider the whole, what's now called the food health nexus. This is some stuff that comes out of IPS Food 2016, which is an extremely set of useful documents. But it just makes the point that losses due to non-communicable diseases because of bad foods that people eat are estimated now at $7 trillion. Obesity is costing $760 billion in causing bad health because we're eating the wrong types of food in the wrong way, and we're producing the wrong types of food. And then there's a whole bunch of other ones that they've analysed there at the end of the day. But the interesting thing is that actually, if we actually look at the costs in terms of health impacts, that many of these costs are avoidable by human choice and human action. We can resolve problems over obesity if we really want to. We can address non-communicable diseases. And that's part of the food system. And understanding that food health nexus is something which has certainly risen to the fore. And this really comes back down to my penultimate slide, and thinking about the paradigms of sustainable food systems. What we have in society, and global agriculture, and as much as true in European and UK agriculture, is a whole bunch of what I'll call lock-ins. There are effectively 9 of them there. All of the outer ones in the ring feed into a lock-in, a concentration of power by certain stakeholders. And the argument about sustainable food systems is that we've got to jailbreak the conventional thinking, and we've got to think in different ways, not just purely production. We've got to think about, we've got to overcome short-term thinking, and short-term thinking is very common to governments, particularly the UK one at present, if I can put a personal view in. We've got to think about whether or not we should be having global export of foodstuffs, or whether they should actually be local, and whether they should be produced through agroecological production systems, which will necessarily be lower yield, but may be more diversified and may support ecosystem services. Because agricultural landscapes provide significant ecosystem services. We've got to break down compartmentalised thinking. There's a whole bunch of things that we've got to do. And those, when you look at policy decisions made in agriculture, are what I call lock-ins, because they're mindsets which we need to think about further. Something to discuss perhaps later on. So measuring what matters for sustainable food systems, I think we've got to move away from GDP growth in relation to agriculture. We've got to move the metrics from these red ones here into thinking about the ones over there in green, which include the health dimension, include livelihood resilience and social equity issues, particularly in lesser developed countries. And finally, and I'd say this with great trepidation because I'm in the management school that looks at supply chains and so forth and so on. When I look at, and I do read supply chain journals a little bit, we think about sustainable supply chains and supply chains, then there are quite often people talk about legal ones, the legal component, the ethical component, and the responsible component. But if you add those three together, I don't believe they necessarily produce you a sustainable supply chain, because it doesn't necessarily address the broader issues that I've talked about this morning and do what actually lasts. I hope you disagree with me so we can have a discussion. Thank you very much.
We have a few minutes for a few questions, if anybody would like to make.
Okay, so who was the inventor of the Green Revolution? Have I got through at all? Sorry? Norman Borlaug. Norman Borlaug. Okay, well, if I've done anything, I've told you something anyway. Many thanks. We can talk about it over coffee and so forth and so on. Oh, sorry.
So, here you go.
Okay. Thanks. Yeah.
That's it.
Yeah, thank you. Okay, good morning, everyone. So, we'll pick up on a couple of things that Martin said, but I think my talk's probably a little bit more general. And it's trying to start to piece together some work that we are starting off in the Philippines with Martin. And also picking up on a new project where Jorge and Andy Lyons are both involved. So my background's in climate science, and I've worked mostly on climate and health, particularly infectious disease. So I'm starting to move now into the food side, so this is quite new to me. So brief tour about climate and climate change. Pick up on the nexus and some of the green economy, the nexus that Martin's already mentioned, and then the parts that I've already said to you. So there's obviously a heightened awareness of climate change through the school strike, and I think it's sort of piqued the public awareness that we're in a climate crisis. And obviously, as Martin was showing with that growing population, we've also got climate probably working against us as well. So why is the climate changing? Well, it's mostly driven by our release of greenhouse gases, and much of the CO2 has actually been released in your lifetime, in the last 20 to 30 years. And I think it's around half. So we're still going up. Some parts of the world, the yellow line is the European Union, and the green line is the US, but of course they're exporting a lot of their manufacturing processes, particularly the carbon-intense processes, to other parts of the world, including China, which is actually maybe plateauing. Okay. So we have reasonably long instrumental observed records of carbon dioxide. How many people have seen the Keeling curve before? Okay, not many of you. So Mauna Loa Observatory in Hawaii started off in 1957, I think it was, during the International Geophysical Year. And, you know, this is when I first came to the university in Liverpool 30 years ago, it was about 340 parts per million. Now well over 400. And it's the one slide and figure I have to update every year. I sometimes update some of the others, but not always. And the impact, if you define the average, the long-term average here as the mean over the 20th century, what you've got here are anomalies from the mean. And you can see that the temperature really started to rise through the 80s and then peaking during the El Nino events and probably still rising again later this year. So it's a sustained rise and not going down and certainly not cooling. You will find some climate skeptics will draw a line through the last 3 or 4 points and say, look, it's cooling. Well, even if it's cooling, it's still well above the long-term average and probably not going back ever. So that's the global land and ocean figures. The land is warming up faster than the ocean. So if you looked at the terrestrial record, it would even be a stronger signal. So that's climate. Climate's a long-term average, and climatologists tend to look at 30-year blocks, assuming that the data's stationary in a warming trend. Then, of course, the data isn't stationary, so the statistics are a bit difficult to work out, but we still do the same. This is average across the bulk of lowland England and Wales, and it was established, has a daily record going back to 1772. It's probably one of the longest daily sequences in the world. What that allows us to do is actually to plot the climate, and we've got a distribution here. So this top line and this bottom line are the extremes, the far spread. And then through the middle, we've got the percentiles. So we've got 10th, 90th and 10th, and then the 5th and 95th. So we've got the climate there as the background distribution. What this is the daily averages across, let's say, a large part of England and Wales for the current year. So this is not this last heat wave, it's not on here yet, but that's the heat wave earlier in July when the UK record was broken. And you can see it's well above the maximum temperature. And again, when the August figures come in, I think we beat the August values as well. We've got the seasonal cycle, of course, on here. It's warmer in the summer than it is in the winter. But likewise, we also had cold spells, not extreme, but down in the lower percentiles. Now, in terms of an agricultural system, many things are very dependent on the temperature at certain stages of crop development, and that can have a big impact on the production. I know a little bit about wheat production, and there I understand that flowering time is absolutely crucial, and there'll be other times in the development of the crop that variability is important. So we've got two things going on. We might be getting more extreme variability, maybe. Certainly for rainfall, I think it's probably proven. For temperature, I don't know, but we're certainly getting higher temperatures because we're in that rising temperature curve. So, food and climate cross many of the Sustainable Development Goals. Who's heard of Sustainable Development Goals? Right. You serious? You've not heard of them? Right, okay, well...
Andy and I are running a workshop tomorrow.
Who's heard of the Millennium Development Goals? Okay, so these lead on from the Millennium Development Goals, and they're UN-based goals on... I'm not going to go through all the details here. Can't remember how many there are now either. Don't test me on that. About 20, I think. And they cover different areas, but food and health and food and climate and health cover many of them. And there are others where it's maybe more marginal that I haven't put in. And these are things that we're aiming to succeed in globally. No poverty, zero hunger, responsible consumption and production, climate action, and then the life on land and life below the water. If you're writing a proposal that's got anything environmental in, if you don't match it to the relevant sustainable development goal, they're going to think you've not been paying attention. So a more complex nexus diagram, but trying to look at that link between water, food and energy. And you might want to add health in there as well, just to make it more complex. You obviously need water for food, and how you produce your food has a big impact on the use of water. Can't remember the figure off the top of my head, but I think in California it's 85% of all the water is used in agriculture. So in many semi-arid or relatively dry areas, there are big agricultural uses of water. It far outstrips domestic and industrial use. You need energy, obviously, to produce the food and also to produce the water. And these things are all intrinsically interlinked. And having a change due to climate or even management or market forces in one of these areas will have a knock-on effect. And that's why we shouldn't study just water, we shouldn't just study food, or we shouldn't just study energy, but we should look at them as a whole. Which means working with lots of people from lots of different areas. The other thing that's coming out is the green circular economy, which is looking at a more efficient use of resources, recycling and reuse and reduction of waste through various types of eco-intervention. And here's a slightly more complex version of the same diagram. Who's heard of circular economies? Who's heard of green circular economies? Okay. So this is a big thing. I don't know where you're all from, but if you're in business now, then looking at circular economies, sustainability, and becoming green is not just part of your corporate social responsibility, but it's also what's going to be demanded from you by your investors and employees. Employees are not going to go and work for a dirty company, and investors are not going to see a long-term investment strategy in investing in you. So you've got to get green. And there's money to be made about going green. It's not just reduction. It's new opportunities, new innovation, new technologies. So let's move on to the Philippines just very quickly. Say very quickly, go through this slide very quickly. Over 100 million people. Nearly 23 million of those live in the wider Manila urban area, and 13 million are nearly in the metro area. If you've tried to drive through Manila, you'll know it's not easy. Long car ride with Martin a couple of years ago. The Philippines still very much an agricultural-based economy. Nearly 28% of the workforce works some way connected to agriculture. And it's an important producer in terms of rice, sugar, largest producer of coconuts, and also abaca, I'm not sure how you pronounce it, Manila hemp. So using hemp for fibre, 87% of the world's production, used in the paper industry. Also a major pineapple user. So why is that all important? Tropical climate, so many of these things grow. I won't go into the details. The only place it becomes temperate is up in these uplands here. And there are differences in the seasonalities in the rainfall cross going from east to west. But let's not go into the detail here. This is a poor slide in terms of stealing it from a website, and it wasn't produced very well. But interestingly, in the tropics, there's really no seasonal variability. And that's something, if you live in the mid-latitudes, you don't really maybe understand. There's no the temperature variation day to day is bigger than the temperature variation through the whole season, but you'll get a distinct rainfall peak at some point, and this is for the northern part of the Philippines. And it can be 2 peaks, it can be 1 peak, depends where you are. So why is the Philippines interesting to me from a sustainable agriculture viewpoint, including fisheries, is that it's probably the typhoon capital of the world. 93 saw 19 cyclones, tropical cyclones, typhoons, hurricanes in the Atlantic, they would be called, and 36 storms going through the area that's under the jurisdiction of the Philippines Met Service. On average, it's about 20 and 8 to 9 crossing the Philippines. So 1993 was particularly bad. You can get between 1,000 and 2,000 millimeters of rain over a few hours at a single site. And there's a distinct season between July and October. And in the north, it's producing about 30% of the annual rainfall. So not all of the rainfall comes from tropical storms. So this is a prediction for this coming year. So there is some information from seasonal forecasting to try and get an idea. And here's not reproduced very well, but here's a climatology of the storms. You can see the more intense seasons, that's July, August, September. And they really come through the center into the north of the Philippines on the whole. That's the part that gets hit the most. So even in the country, there's a difference in the typhoon climate. There's a recent one when I was putting this together last week. Pick them up on satellites now, and again, it's taking that sort of track. In fact, it's going to predict you to actually miss the north of the Philippines. So you may have heard of Haiyan, one of a super typhoon. One of the impacts of climate change is perhaps not changing the number of storms per year, but increasing their intensity. So about $2.2 billion of damage, 6,300 deaths. Yolanda is its local name, and 225 million agricultural damage. So many hundreds of thousands of hectares lost, plus the impacts on fisheries. These are coconut trees that have been blown down, and here is the flooding of rice paddy. And that wasn't a normal flooding, that was actually due to the hurricane, or the typhoon, sorry. So the main hits were in the infrastructure. I forgot to put in how many Filipino pesos there is to the dollar. I can't remember off the top of my head. It's in dollars, the bottom line's in dollars, in millions of dollars. Biggest hits were in the social sectors and then in the infrastructure. Hit in the agriculture, I should look down this line, sorry. Social structures, then agriculture particularly hit, and then the infrastructure. So agriculture took a major hit during the hurricane, during the typhoon, sorry, compared to other sectors. What about the future? Looking forward in time towards the end of this century, compared to recent climate, it depends how many greenhouse gases we release. If we take a middling outlook, then we're looking at moderate warming. Maybe only no more than 2 degrees. If we carry on as we are at the moment, then we're looking at 3 to 4 degree warming. So it's going to warm whatever we do. Obviously, there's a distribution on those warmings, and here you've got this box whisker plot. The whiskers are the 5th and 95th and the 5th percentile, and that's the interquartile range, 25th to 75th here. And you can see there's definitely a shift. It looks like a shift in the distribution. depending what we do in terms of controlling greenhouse gas emissions. Rainfall, not such a strong signal perhaps, but certainly if we go along carrying on with our emissions as they stand, it will be, these are in millimetres per day, so we will be adding maybe it's like 17 to 20% extra rainfall a year. No real trend in the rainfall, and that's typical what you see out of the global models. Whether you believe the rainfall outputs is another matter. But we have to assume maybe the rainfall stays the same. Adding them together and going for effective rainfall, which is precipitation minus evapotranspiration, so that's the available water for whatever you're trying to drive, whether it's an irrigation system, a crop, hydro scheme, then there's no signal here with the lower emissions. The hatch means that the noise is bigger than the signal. Those signals starts to emerge, and it would say if we carry on business as usual, higher emissions, then it's slightly wetter. The one thing I sort of started to look at also was the humidity levels, because there is a limit to which humans can work, and they won't be exceeded here in the Philippines, doing some various calculations online. But it's going to become more humid, so it does mean that you may lead to different pests and diseases becoming more prevalent. It will have an impact. A lot of the agriculture is quite manual or low intensity. And it will become more difficult to work, although not getting towards the limits that we might see around the Arabian Sea and parts of southern India. Okay, new project, an Interreg project called Neptunus that we're a few of us in the room are involved with. Pulling these things together, this nexus between water, energy, and seafood. Through eco-innovation and circular economies, trying to reduce wastage, and trying to see how climate change and climate variability might have that impact. The nature of the project is it's Atlantic area, so only regions with Atlantic-facing coasts, including Merseyside. And I've always thought that was the Irish Sea, but never mind. Are allowed to bid in, and we've got partners from the UK, us, Ireland, 2, a couple in France, about 3 or 4 in Spain, and some in Portugal. So I think it's going to be a great project to go and visit nice places. Well, that's not what it's about, I know. So they're trying to produce eco-labelling. I don't know if anyone seen about eco-labelling. Anyone interested in consumers and okay, so trying to put eco-labelling on that things are sustainable. And as I said, there's a business here, business in producing green products. People want to buy things that are green. And this is just taken from the proposal, but it's very similar to things I said earlier. It provides opportunities producing a circular economy. And these are the things they're saying, if you're working out there, these are things you need to do. One of the things that came out looking through parts of the literature is that the people that are more engaged or reliant on commercial fishing are more vulnerable. The red, I thought I'd written it on here somewhere, yeah. Red means more vulnerable, yellow means less vulnerable, compared to other communities living in the same location. So they're much more vulnerable, poverty, personal disruption, labour force, housing characteristics. So often those people in primary production and in processing are at the lower end of the socio-economic spectrum. So here's the whole supply chain, which I will dare not go through in this school. But we're going to try and follow the supply chain through from harvesting, through port activities to processing, and then if it's an international trade, then it goes back through a whole set of other processes. I don't think we'll be able to do them all in the project, but we will look at some of them. So what are we up against in the Atlantic? Well, the red line is the Atlantic. It's a bit noisy. This is a warming temperature up here, or temperature anomalies. It's warming faster than the rest of the oceans, for whatever reason. Probably more noise because it's not averaged across many oceans, but it is noisy, it is variable. We may be seeing an increase in storm activity, which can affect harvesting and distribution. And that's on land as well as, remember, these are coastal communities. It's not just at sea, it's also where your processing plants are, maybe the start of your distribution chains. And the warming is affecting the spawning grounds and also the migration of fish to colder waters. So there's two things going on there. Those are our partners, these are our full partners, and these are our associates who are stakeholders. And some of these groups actually are pretty much, this one here is a stakeholder umbrella group. So stakeholders are in from the start, and they're a key part of the project, as they should be in all projects these days. So we've got some nice places to visit: Galway, Bordeaux, I think currently Galicia, Bordeaux again. All right. Okay, so in summary, we have a climate emergency is the key term now. Global heating, not global warming. Really isn't a gentle thing, it's a nasty thing. So food for providing nutrition and livelihoods feature across the Sustainable Development Goals, which you're all going to go back and read about. We've got to drive a green, sustainable, circular economy featuring eco-innovation. And that's going to be a demand in every industry, but particularly in food production and supply. We talked a bit about the Philippines, a large population with a large proportion engaged in agriculture. Sits right in one of the worst places in the world for tropical storms and cyclones. And it has globally significant production of certain food commodities and fibre. What we need to do, I think, is to develop, and that's been going on under a World Meteorological Organization banner, and that's the use of the climate data that's there and forecasts and climate projections to support these industries. And Neptune, as hopefully you remember because we've just talked about, but it's about eco-labelling, eco-innovations that add value and cross-cut the sea, food, water, energy domains. Okay, thank you.
Time for a few questions.
In terms of the eco-label, is that based on, like, are you trying to engage businesses in adopting practices, and then is the intent like the businesses that adopt certain practices that will help reduce environmental impact can use this labeling, or is it looking at, for example, the environmental impact in the supply chain, and how reliable do you think sort of assessing environmental impact of supply chains is?
I don't know the straight answer to most of those. I think part of this is trying to work out how we eco-label, because it hasn't really been done, as far as I know, through the full supply chain in this industry. I'm trying to think of all the points you said. Was it something, I can't remember, can you remember?
Is it a bit,
yeah.
like, I guess, is it looking at the environmental impact of the supply chain, or whether a business is adopting practices recommended by Neptunus?
Okay, I think it's a bit of both. I mean, Neptunus it's only just started, and we haven't come up with a list of recommendations.
Okay.
So we're trying to map what goes on, and then look for, as Jorge would say, the uncertainties at each stage, and how we can help them address those uncertainties. So my interest would be on the climate uncertainty. but Jorge and Andy's would be in different areas. So I think it's actually both. I think one is to actually go out and understand where there's waste, and it's fuel use, it's reducing debris, reducing bycatch, but then the wastage through the whole chain. And then I'm not sure if there's an international standard for this. Not my bit, but I guess you'd look to see how well the suppliers are hitting that demand. But it's labelling it through the whole chain, not just for each part. So the sustainable fisheries, which is quite popular, people looking for fish sourced from sustainable sources, it doesn't, for example, I don't want to knock it because it's good, but it doesn't tell you anything else about the supply chain.
It's actually a very interesting question. This particular project hasn't just started, but I'm working on another project in the textile industry with clothing, and ethical and eco labelling really doesn't penetrate the supply chain very much at all. Okay, so where you can see it's actually relatively superficial compared to the full supply chain that is present. So it is actually a pertinent, it is a good question, and something that we will explore in the project. Much more detail.
Okay, thanks for the questions. I think we've got a break.
Yeah, break.
Jorge, should I stop the video?
Yes, please. By the way,
Should I stop or pause?
we-
Pause.
yeah.